Hello, this is Mrs. Ringrose, and we are back at it again, trying to find out all the different ways of solving linear equations when it has one variable. So today's goal is to be able to handle equations that have fractions or ratios. And I just wanted you to know what a ratio is, and then we'll talk about what a proportion is. And there's lots of different ways to solve these, and so you just have to stick with the strategy that you think makes the most sense to you. So a ratio is a comparison of two numbers. Really, I should be using the word quantities because, as you can see in the first example, it's not just a number on top, but it says 2x, so it's actually a variable term. So a ratio is a comparison of two numbers. It looks like a fraction. All right, so don't be afraid of the fraction. It's just saying 2x to that 9. A proportion is when two fractions, I'm sorry, I want to use the word ratio now, is when two ratios are set equal to each other. So if you look in the first example, I'm told that 2x over 9 is equal to 8 over 3. The best way to do that kind, when I don't have anything being added on either side, the best way to handle that kind is by doing what we call cross-multiplying. So cross-multiplying is, because we have this equal sign, it's saying that, because basically what I could do is I can multiply both sides by 3, to get rid of that 3, or multiply both sides by 9. Actually, probably make more sense. So it takes a couple of extra steps. So what we do is we make a big cross, and we multiply those things across the equal sign. So on one side, it's going to be 2x times 3 equals 9 times 8 on the other side. So I need to learn how to spell. What we're doing is cross-multiplying. All right, now I'm going to simplify. 2x times 3 is now 6x. 9 times 8 is 72. I still need to do something to get rid of the 6 because I want my x all by itself. So the opposite of that multiplication is going to be division. So I'm going to divide both sides by 6. And 72 divided by 6 is 12. So we divided both sides, and then I simplified. And I can always go back and check my work as well. Another way to do this one, just in case you really didn't like cross-multiplying, is called clearing the denominator, which we might use in different examples. So first I'm going to multiply both sides by 9. So then I get 2x equals 8 times 9 is 72 over 3, because that 3 is still in the bottom. Then I'm going to want to go ahead and simplify that. So 72 divided by 3 is 24. And I still have two x's on one side, so I need to get rid of that. If I divide both sides by 2, I get the same answer, which is 12. It's a miracle when this gives you the same answer either way. Personally, I like cross-multiplying when it looks like that. All right, so I have another example here. This example has an x in the denominator, but because I have two ratios set equal to each other, I can cross-multiply again, and I get 3 times x equals 8 times 12. And which simplifies to 3x equals 96 there. And then I'm going to want to have to get the x by itself by dividing both sides by 3. And I get 3 goes into 9 3 times, and 3 goes into 6 2 times. So divide both sides by 3 to undo or cancel out that multiplication. And that's my answer. All right. I'm not going to do this one the other way because it's really so much more straightforward when you cross multiply. All right, here's an example that's a little bit more complicated. So when you have a whole expression like that above the fraction bar, it's really is like a grouping symbol. So I'm going to throw those parentheses in there before we get started to hopefully make this a little bit clearer. Again, I have two ratios set equal to each other, so I'm going to cross multiply again. And what that's going to look like is with the parentheses, I have 3 times 5w minus 3. We need those parentheses because the 3 has to go on everything. And 2 times 3 plus 8w. So again, I cross multiplied. And I'm going to distribute that 3, and I get 15w minus 9, and I have to distribute that 2, 6 plus 16w. And now I need to start getting my w's to one side. I'm going to move the smaller one. So I had 15w, and I'm going to minus 15w from both sides. These two cancel out, which is what I wanted. So now I have negative 9 equals 6 plus 1w. And I'm trying to get everything away from the w, so my next job is to subtract a 6 from both sides. So negative 9 minus 6. And then I get negative 15 equals 1w, which is what I want. And then you really should go back and check it. But again, the extra added skill here is that we're going to cross multiply so that I can simplify both sides and get my w all by itself. All right, stay with me because all these fractions are going to get more fun. I just have 2 more examples. All right, if you notice this example, there isn't just one ratio over on this side. So cross multiplying is actually not appropriate. What we can do with this one is a strategy that's called clear the denominator. Oh, I have it written up there, the objective. So there's a couple different ways you can do this. You can find a common denominator with 2/3 and 1/2. 2/3 and 1/2. You can find a common denominator with 5/6. Then you can try to go from there. But clearing the denominator is the way to go because I don't really want to see those fractions. I would circle the biggest denominator and bring that and multiply everything by that number. All right, so what happens here is these 6's cancel out on the right side, and I'm just left with 5, right? Because when you have 6 on top and 6 on the bottom, they cross out. And then I have to distribute that 6 inside. So 6 times 2 over 3x plus 6 times 1 over 2. And then I need to simplify. 6 times 2 is 12. 12 divided by 3 is 4. So now I have 4x. My fraction is gone. Plus 6 times 1 is 6. Divided by 2 is 3. So now that fraction is gone. And now I'm left with an equivalent equation. 4x plus 3 equals 5. I'm actually not going to finish this one because this video is getting kind of long and I want to look at the next one, but you should finish. You would subtract 3 from both sides and then divide by 4. All right, and lastly, again, I have fractions all over the place. This is a nice fraction buster equation. So using the strategy I just showed you in the top one, what is my largest denominator? That would be 8. So I'm going to try multiplying everything by 8. And see if that helps makes this any prettier. So I have 8 times 7 over 8x plus 8 times 3 over 4 equals 1 times 8 over 2x plus 3 times 8 over 2. These 8's cancel. I'm left with 7x plus 8 times 3 is 24. 24 divided by 4 is 6. 1 times 8 is 8. 8 divided by 2 is 4 x's. And then 3 times 8 again is 24. And 24 divided by 2 is 12. And then again, you're left with an equation that is so much more fun to solve. I can subtract 4 x's from both sides, and then I can subtract 6 from both sides, and divide, and I get an amazing answer that doesn't look ugly at all, considering what the equation started with. All right, so hopefully this will help you understand some strategies for solving. You have this to work on your own, and please come and see me if you need any help or if you didn't understand the video that I just did. But I expect you guys all to be fraction masters. Thank you. Have a good day.